What if I told you everything you think you know about water dinosaurs is wrong? That massive beast from Jurassic World that leapt out of the water and swallowed the Indominus Rex whole? Not a dinosaur. That Plesiosaur toy in your kid's dinosaur collection? Not a dinosaur either. Every single one. If you've ever pointed at a Mosasaurus, a Plesiosaur, or an Ichthyosaur and called it a water dinosaur, you fell for the biggest lie in paleontology. They were marine reptiles, a completely separate group, about as related to actual dinosaurs as you are to a kangaroo. And that's not even the crazy part. Once you strip away all those imposters, you're left with a fact that should genuinely bother you. In 233 million years of dinosaur history, over 10,000 species, animals that conquered every continent, including Antarctica, creatures ranging from smaller than a pigeon to longer than a Boeing 737. Not one of them figured out how to live in the ocean full time. Think about that for a second. Mammals cracked the code. Whales, dolphins, seals. We've been around for way less time than dinosaurs, and we've sent dozens of species into the deep. Reptiles did it. Sea turtles, sea snakes, and those marine reptiles everyone mistakes for dinosaurs, they absolutely dominated the oceans for over 150 million years. But actual dinosaurs, the most dominant land animals in Earth's history, they never figured it out. And there's a reason for that. Actually, there are several. And once you understand them, you'll realize that dinosaurs weren't just unlucky. They were trapped. But first, we need to settle something important. If all those famous sea monsters weren't dinosaurs, then what were they? And what actually makes a dinosaur a dinosaur? If you want to know whether something is a dinosaur, you don't look at how big it is. You look at its hips. Seriously, the hips. Dinosaurs have one feature that separates them from every other reptile that ever existed. A hole punched right through their hip socket, not a shallow depression, an actual opening where the leg bone connects. Sounds like a small detail, right? It's not. That tiny hole changed everything. Most reptiles walk with their legs sprawled out to the sides. Think of a lizard or a crocodile. Their limbs stick outward, and when they move, their whole body has to swing side to side. It works, but it's inefficient. But that hole in the hip socket, it allowed dinosaurs to stand with their legs directly underneath their bodies, straight down, like pillars holding up a building. This was a game changer. Suddenly, dinosaurs could run faster, support more weight, grow bigger. That's why T-Rex could sprint on two legs, and sauropods could carry bodies the size of buildings without collapsing. That one little hole gave dinosaurs a structural advantage that no other reptile could match. Now think about Mosasaurus, that terrifying ocean predator from Jurassic World. Check its hips. No hole. Its legs sprawled out to the sides before they eventually evolved into flippers. Mosasaurus wasn't a dinosaur. It was a lizard, closely related to modern-day monitor lizards and snakes. What about Plesiosaur? The long-necked one everyone thinks is the Loch Ness Monster? No hole, completely different lineage. Evolved from a separate group of reptiles called Nothosaurs about 250 million years ago. Ichthyosaur, those dolphin-looking things, no hole either. Scientists still aren't entirely sure where they came from, but it definitely wasn't the dinosaur family tree. These animals lived at the same time as dinosaurs. They were big and reptiles. They looked prehistoric and terrifying. But calling them dinosaurs is like calling a bat a bird because they both fly. The hip socket doesn't lie. And when you check the hips of every single marine reptile from the Mesozoic era, none of them pass the test. So, no water dinosaurs were swimming alongside these creatures. The oceans were dominated by marine reptiles. Dinosaurs stayed on land. Which brings us to an obvious question. If these marine reptiles figured out how to conquer the oceans, why couldn't dinosaurs do the same? What was stopping them? Turns out their own bodies were working against them. And it starts with a problem they could never solve. And the first problem is every dinosaur that ever existed laid hard-shelled eggs. No exceptions. We have the fossils. We have the embryos. The evidence is airtight. And this single fact, It was a death sentence for any dinosaur trying to conquer the ocean. Because here's the problem with dinosaur eggs. They breathe. Tiny pores cover the shell. Oxygen goes in, carbon dioxide comes out. It's how the embryo survives. But submerge that egg underwater, those pores flood. Gas exchange stops. The embryo suffocates before it ever hatches. Even high humidity can kill a developing dinosaur egg. Full submersion, game over. So how did marine reptiles solve this? They ditched eggs entirely. Ichthyosaurs gave birth to live young. We have fossils catching them in the act. Babies emerging tail first, exactly like dolphins. No land required, ever. Plesiosaurs did the same. Scientists found a pregnant plesiosaur with a single large baby curled up inside her. She was going to give birth in the open ocean, probably never touching shore her entire adult life. Mosasaurs? Same deal. Live birth, complete freedom from land. This ability, viviparity, was the golden ticket, the one adaptation that unlocked full-time ocean life. But dinosaurs, they were locked into egg-laying, permanently. And it wasn't just dinosaurs. Their entire group, the archosaurs, seems almost incapable of evolving live birth. Crocodiles lay eggs. Birds lay eggs. Every archosaur we know of lays eggs. Meanwhile, lizards and snakes, they've evolved live birth at least 115 separate times. Some sea snakes give birth in the open ocean and never touch land their entire lives. But archosaurs? In 250 million years of evolution, essentially 0 cases of live birth. There's one exception, a marine reptile called Dinocephalosaurus from 245 million years ago. Scientists found a fossil with an embryo inside, proof of live birth. But Dinocephalosaurus wasn't a dinosaur, it was an early archosauromorph, a distant cousin, not part of the dinosaur family tree. Actual dinosaurs? They stayed trapped, which meant any dinosaur that wanted to live in the ocean full-time would have to crawl back onto land to lay eggs. Every single breeding season. Without fail. Sea turtles do this. But sea turtles are small. Now imagine a 50-foot Spinosaurus trying to drag itself up a beach to lay eggs. Evolution looked at that problem and said, nah, not worth it. But the egg problem wasn't the only thing holding dinosaurs back. Their bodies had another built-in flaw, one that would turn them into floating disasters the moment they tried to dive. Dinosaurs were built like pool floats. That's not an insult. That's biology. Most dinosaurs, especially the big theropods and sauropods, had hollow bones filled with air, like a bird's skeleton. And those hollow bones weren't just empty space. They were connected to a network of air sacs running through their entire body, part of their respiratory system, the same setup that lets birds breathe more efficiently than any mammal. On land, this was a superpower. But in water, this was a death sentence. All that air trapped inside their bones and body cavities, it made them float, not gently bob at the surface, float uncontrollably, like an inflatable toy that keeps popping back up no matter how hard you push it down, and it gets worse. Scientists actually modeled this. They took Spinosaurus, the closest thing we have to an aquatic dinosaur, and ran computer simulations to see how it would behave in water. The result? A disaster. Spinosaurus was too buoyant to dive. Its body kept trying to rise, and because the air wasn't evenly distributed, it would have been unstable, constantly tipping, rolling, fighting its own body just to stay upright. One researcher put it bluntly, Spinosaurus was simply not an animal that in your wildest dreams would be dynamic underwater. The animal we thought was the ultimate swimming dinosaur couldn't swim properly. Now compare that to animals that actually thrive underwater. Penguins have solid, dense bones, no air pockets. That density acts like ballast. It helps them sink and maneuver underwater instead of bobbing at the surface like a cork. Some diving birds can actually squeeze their air sacs flat before a dive, reducing buoyancy on purpose. Whales have dense bones too. So do seals. So did ichthyosaurs. Every successful aquatic animal solved the buoyancy problem. They either evolved denser bones or found ways to compress the air inside them. Dinosaurs couldn't do either. Their entire respiratory system was built around those air sacs. It's what made them so successful on land. But evolution couldn't just rip that out and start over. You can't redesign a lung system mid-game without killing the animal. So dinosaurs were stuck with bodies that desperately wanted to float, skeletons full of air, a breathing system that worked against them the moment they tried to dive. Could one have floated on the surface? Maybe. But actually diving, hunting underwater, chasing prey into the deep? Their own bodies said no. So dinosaurs' bodies were basically inflatable rafts. The odds were stacked against them from the start. But did any of them even try? Actually, yes. A few species got surprisingly close, and the story of how close they got and why they still failed might be the most frustrating part of this whole thing. Let's start with the obvious one, Spinosaurus. For decades, Spinosaurus was just that dinosaur with the sail on its back. Big theropod, ate fish, nothing too crazy. Then 2014 happened. New fossils revealed something wild. Spinosaurus had dense bones, way denser than other theropods. It had tiny hind legs, a long paddle-shaped tail. Suddenly, scientists weren't just calling it a fish eater anymore, they were calling it aquatic. The headlines went nuts. First swimming dinosaur discovered. Finally, proof that dinosaurs conquered the water. Except, not quite. In 2022, two major studies dropped, and they completely contradicted each other. One study looked at bone density. Spinosaurus had bones as dense as penguins and hippos, animals that spend serious time submerged. The researchers argued this was proof Spinosaurus was diving for fish, actually hunting underwater. But the second study? They built computer models, simulated how Spinosaurus would actually move in water, and the results were brutal. Too buoyant and unstable. The animal would tip over. It couldn't dive properly and couldn't chase prey. Their conclusion? Spinosaurus wasn't a swimmer. It was a wader, like a giant, terrifying heron. It stood in shallow water and ambushed fish from above. Deadly? Absolutely. But not aquatic. Not even close. The dream of a swimming dinosaur died right there. But Spinosaurus wasn't the only candidate. In 2022, scientists announced a brand new discovery from Mongolia, a dinosaur called Natovinator. This thing was tiny, about the size of a duck, a small raptor from the late Cretaceous around 71 million years ago. And its skeleton had something no non-bird dinosaur had ever shown before: streamlined ribs. In most animals, ribs stick outward, but Natovinator's ribs swept backward, hugging the body tight, creating a sleek hydrodynamic shape, the exact same rib structure you see in diving birds like cormorants and penguins. This wasn't a coincidence. Natovinator was built for water. It had a long neck, tons of teeth, flipper-like arms. Everything about this animal screamed, "I hunt in lakes and rivers." So was this it? The real aquatic dinosaur? Not quite. Natovinator was almost certainly semi-aquatic. It probably spent a lot of time in water, diving for fish and small prey. But fully aquatic? Living its entire life in the ocean? No evidence for that. It still would have nested on land, still would have been limited by those same biological chains. Close, but not there. And then there's Halscaraptor. Discovered in 2017, this weird little raptor had flipper-like forelimbs and a snout packed with sensory neurons, the kind aquatic animals use to detect prey underwater. Scientists announced it as semi-aquatic, another dinosaur that took the plunge. But in 2022, that claim got challenged hard. Researchers measured its bone density. And here's the problem. Halscaraptor had light bones, low density, the opposite of what you'd expect from an aquatic animal. The scientist who originally described it fired back. He pointed out that swans have low bone density too, and they're definitely aquatic. The debate is still ongoing. Some scientists think Halscaraptor was semi-aquatic. Others think the evidence doesn't hold up. What we know for sure? It wasn't fully aquatic. None of them were. Spinosaurus waded. Natovinator dove in freshwater. Halscaraptor might have swum sometimes. That's as far as dinosaurs ever got. Millions of years, thousands of species, and the best they could manage was dipping their toes in. But there's one more barrier we haven't talked about yet. Even if a dinosaur solved the egg problem, even if it evolved dense bones. The ocean wasn't empty, something else was already there, and they weren't sharing. By the time dinosaurs even existed, the seas were already dominated, ruled by predators that had been perfecting aquatic life for millions of years. Ichthyosaurs got there first, 250 million years ago. While dinosaurs were just starting to walk, these things had already evolved into dolphin-shaped killing machines. Some grew over 60 feet long. They had eyes the size of dinner plates, the largest of any animal ever, designed to hunt in pitch-black depths where sunlight never reached. They owned the oceans before dinosaurs even knew what an ocean was. Then came the Plesiosaurs, 4 massive flippers, long necks, built for cruising through open water and snatching prey from below. They dominated coastlines and shallow seas across the entire planet. And just when those two started declining, Mosasaurs showed up. These were basically sea lizards on steroids, related to monitor lizards and snakes. Some species hit 50 feet. They were aggressive, they were fast, and they filled every gap the Ichthyosaurs and Plesiosaurs left behind. For over 150 million years, the oceans had apex predators, specialists, animals that had spent countless generations adapting to life underwater. Streamlined bodies, dense bones, live birth, echolocation, pressure resistance, every advantage you could ask for. Now imagine a dinosaur trying to break into that market. Some clunky theropod that floats like a pool toy, can't dive properly, competing against animals that were born in the water, hunt in the water, and never have to leave. That's not competition. That's a death sentence. Evolution doesn't reward bad ideas. If going aquatic meant getting outcompeted and eaten by animals that already perfected it, why bother? Natural selection would have killed that experiment fast. And there's another layer to this. Most animals that successfully transitioned to water started small. Whales, their ancestors were dog-sized. Seals, small and nimble first. Mosasaurs, they evolved from little coastal lizards. Starting small lets you slip into ecological niches, find food sources the big predators ignore, build up adaptations slowly without getting murdered. But dinosaurs? The average dinosaur weighed nearly 4 tons. These weren't small, sneaky animals testing the waters. They were giants. And giants don't sneak into anything. A house cat-sized early whale could hunt fish in shallow rivers without attracting attention. A 2-ton theropod splashing around, every mosasaur within a mile would come looking. The oceans were full. The competition was lethal. And dinosaurs were too big, too awkward, and too late to the game. So they stayed on land, where they were already winning. But after everything we've covered, you'd think the story ends there. Dinosaurs never made it. Case closed, except that's not entirely true. Because there is a group of dinosaurs that figured it out, that actually colonized the oceans. And they've been hiding in plain sight this whole time. Birds are dinosaurs, not descended from dinosaurs, not related to dinosaurs. They are dinosaurs, living, breathing, flying dinosaurs. This isn't some fringe theory, it's scientific consensus. Every biologist, paleontologist, and researcher who studies this stuff agrees. Birds are theropods, the same group that includes T-Rex, Velociraptor, and Spinosaurus. When the asteroid hit 66 million years ago and wiped out the giant dinosaurs, one lineage survived. Small, feathered theropods that could fly. They made it through the apocalypse, and they evolved into every bird you see today. Which means, technically, aquatic dinosaurs exist. Penguins, dinosaurs, cormorants, dinosaurs, ducks, geese, pelicans, puffins. All dinosaurs. Every bird that dives for fish, swims across lakes, or hunts in the ocean is a living aquatic dinosaur. But that feels like cheating, right? When people ask about water dinosaurs, they're not thinking about seagulls. They want the ancient ones, the Mesozoic monsters that swam alongside plesiosaurs and mosasaurs. Fair enough. So let's go back in time. Did any ancient dinosaurs actually make it into the ocean? The answer is yes, and its name was Hesperornis. Hesperornis lived during the late Cretaceous, around 83 to 72 million years ago, right in the middle of the dinosaur age. While T-Rex was stomping around North America, Hesperornis was diving through the western interior seaway, a massive ocean that split the continent in half. And this thing was built for water. Nearly 6 feet long, powerful hind legs designed for propulsion, a streamlined body that cut through water like a torpedo. It swam the same way modern loons and grebes do, feet pumping, body horizontal, absolutely lethal underwater. But the wildest part? Hesperornis had almost no wings, just tiny, useless stubs where wings should be. This bird had completely abandoned flight. It didn't need to fly. It had committed fully to the water. And it had teeth. A mouth full of sharp, backward-pointing teeth, perfect for snatching fish and making sure they didn't escape. Hesperornis wasn't just swimming around casually, it was an active predator, a hunter, chasing down prey in open ocean water. This wasn't some bird that occasionally got its feet wet. Hesperornis was genuinely marine. It spent its life at sea, hunting, swimming, diving. Scientists believe it probably only came to shore to breed, just like modern seals and sea lions. So there it is, an actual dinosaur that colonized the ocean 80 million years ago. Case closed? Not quite, because Hesperornis wasn't fully aquatic either. It still laid eggs. Hard-shelled eggs, just like every other dinosaur, which meant every breeding season, Hesperornis had to haul itself onto land. Find a nesting site, lay its eggs, wait for them to hatch. For a bird with tiny, useless wings and legs built for swimming, walking on land would have been a nightmare. Scientists think Hesperornis probably flopped around on its belly, pushing itself forward like a seal. Vulnerable, easy prey for anything hungry. This was the cost of being a dinosaur. No matter how well adapted to water Hesperornis became, it couldn't escape the egg problem. That biological chain that kept every dinosaur tied to land, no matter what. And Hesperornis wasn't alone. Other toothed seabirds existed during the Cretaceous. Ichthyornis was another, a flying seabird with teeth that probably lived like modern terns. Baptornis was similar to Hesperornis but smaller. For a brief window of time, dinosaurs actually had a foothold in the oceans, multiple species, diverse lifestyles. They were finally starting to figure it out. Then the asteroid hit, 66 million years ago, the Chicxulub impact, and everything changed. Hesperornis went extinct, Ichthyornis went extinct, every toothed bird in the ocean disappeared. The marine dinosaur experiment ended before it really got started. But birds themselves survived, small ones, the ones that could hide, that could eat seeds and insects, that didn't need the ocean food chains that collapsed overnight. And over the next 66 million years, they tried again. Penguins appeared. Somewhere between 60 and 62 million years ago, a group of birds in the southern hemisphere started evolving for swimming. Today, some penguin species can dive over 800 feet deep. They can hold their breath for 20 minutes. They spend months at sea without touching land. But they still lay eggs. Every penguin, no matter how aquatic, has to return to land to breed. The same limitation that held back Hesperornis 80 million years ago still holds back penguins today. Cormorants, grebes, loons, auks, they all face the same problem. Incredible swimmers, deadly underwater, but chained to land by eggs they cannot abandon. The dinosaur curse lives on. So what's the final answer? Are there aquatic dinosaurs? Technically, yes. Birds are dinosaurs, and plenty of birds are aquatic. Hesperornis was marine. Penguins practically live in the ocean. But fully aquatic, living their entire lives in the water, never touching land, giving birth at sea like a whale or an ichthyosaur. No dinosaur has ever done that. The eggs wouldn't allow it. The bones fought against it. The competition crushed any attempt, and every dinosaur that tried either stayed semi-aquatic or went extinct trying. And honestly, they probably never will. If you learned something new today, subscribe. We break down the wildest stuff in science and history daily. Drop a comment. What topic should we cover next?